Yes, moving on. Hello, everyone. Welcome to lecture 8. So we have 3 more lectures for this semester. Yeah. So today the topic is ChatGPT. So the techniques behind the ChatGPT are mostly InstructGPT and also GPT-3, GPT-4. So we know GPT-3 was published in June of 2020. However, ChatGPT was published almost December of 2022. So after ChatGPT 3 was finished, they spent 2.5 years. Right? They spent so much time to eventually they can have a product, ChatGPT. So all the work of ChatGPT, I mean the work between GPT-3 and ChatGPT was finished in the COVID-19 time. Okay. Yeah. So for today's lecture, we have 3 points. Firstly, let me briefly introduce ChatGPT. Probably you are very familiar with ChatGPT already. And second part is the key part of today's lecture is InstructGPT. The key difference between GPT-3 and ChatGPT is InstructGPT. And the number 3 part is GPT-4. Okay. So probably you know OpenAI very well, but probably I don't know you heard another company or not. Let me so have you heard this company, Skill AI? So I believe most of the work of ChatGPT was finished by Skill AI. After this lecture, you will know Skill AI is a startup to help different enterprises to label the data for AI model. Okay, good. Yeah. Yeah. So ChatGPT is very fancy. You know ChatGPT very well, right? You can use ChatGPT to write a code. Hopefully, ChatGPT can give you more ideas to help you to find some deep bugs. The bugs may be very tiny bug, but can cause the whole system crash, give you wrong answers. And also, hopefully, ChatGPT can give you better implementation to improve the performance of your code. By the way, have you ever tried using ChatGPT in coding? Okay, good. Yeah. Yeah. ChatGPT can help you. I think that's very important for the future. Give you more ideas. Yeah. So here is a demo, but it's not important, right? If you want to learn something, ChatGPT can give you a demo and also to explain, right? Give you all the information you need. And the ChatGPT can also make our life better, right? For example, you want to go to Paris, go to New York, go to Munich, ChatGPT can make a schedule for you. Yeah. I think today is still not the best. Right? If you want to travel to some place, if you use ChatGPT, I believe their recommendation is not the best. In the future, we hope ChatGPT can be your default choice when you want to travel, and be a travel guidance in the future. And if you like, you can also use ChatGPT to to do something real. So basically, let me give you a summary. ChatGPT is a powerful product on top of LLM. Right? It's actually a model, but it's more than a model. And you can use ChatGPT to process almost all the natural language processing tasks. That's very important. The key idea of ChatGPT is still machine learning, and also today's topic, instruction learning, instruct learning. Yeah, so it's easy to use ChatGPT. You just go to the web page of OpenAI. There are also some other similar products today, like an Anthropic Cohere or something. There are many different options. But ChatGPT was a pioneer for this direction. Okay, now let's go to the key part of today's lecture, InstructGPT. Basically, the idea is instruct learning. So why do we need InstructGPT? So why don't we just publish ChatGPT in June of 2020, right? Because in June of 2020, we already have GPT-3. So why GPT-3 is not good enough? That's what we want to answer. I hope you know the answer after this lecture. So before I introduce the InstructGPT now, let me briefly review GPT-3. I hope you remember GPT-3 has 175 building parameters. So we also needed to know how can we compute the number of parameters. Please review lecture 5 or lecture 6. Lecture 6, we have a quiz. How can you compute the number of parameters of GPT-3? And also, the loss function of GPT-3 is very easy. It's predicting the next token, next word. For each prediction, we just pick one word from 50K words. We have 50K options. Right? The vocabulary size is 50K. We pick one. Probably only the top 20 words matter. Because maybe the probability of the number one is 30% and maybe 8%, 7%, 9%. Only the top 20 words have a very high probability. So even we have 50,000 different options. And also, because each step is kind of sampling token from so many different tokens, which means next time, even you ask the same question, you may get a different answer because you have randomness here. Every step, it's a sampling operation. That's GPT-3. And so here is a visualization for the loss for the operation of GPT-3. GPT-3 is just predicting the next token, right? Now we have 3 tokens. The context is a robot master. Now the context has 3 words. The GPT-3 just predicts the next word. The robot master obey. And then next step is predict the orders given. Predict the word, the token one by one. So the author of GPT-3, they use 300 billion tokens to train the model. They have lots of data. That's why they make the model so smart. So that's just the loss function. and also the key operation of GPT-3. However, why do we need a new product? Because GPT-3 is not good enough. If you like, you can try. So you ask a question to GPT-3 by natural language, by the human being language. GPT-3 cannot give us a good, the perfect answer. So like explain the moon landing to a 6-year-old in a few sentences. That's the answer of GPT-3, right? These answers are very disappointing. They are just doesn't make too much sense, right? It's more like instruction here. Okay. So the concern of GPT-3 is GPT-3 may be very powerful, but GPT-3 is not able to communicate with the human being very well. That's why we need a new model or new product, which is InstructGPT or ChatGPT. So here is the answer of InstructGPT. You see the answer is much better. How can InstructGPT get a much better answer? But firstly, we know ChatGPT or GPT-3 is not good enough. And also the second concern is ChatGPT can generate some very bad answer, toxic or very biased answer. I think to all the nations or all the countries, so people have some common sense. For example, you cannot say something bad in US or in China or even in Singapore. So ChatGPT now is much better than GPT-3 for controlling the output, controlling the topic of the output. And also, we know GPT-3 has the power of in-context learning. Let me also briefly review a zero-shot, one-shot, few-shot. Zero-shot means the model hasn't learned the task. You just give the task to the model can give you an answer. The one-shot is you give the instruction to the model and then you give the model an example. The model just use this example to finish the task. A few shot is you give the model an instruction, the model, and also several different examples. And then the model just use these demos to solve the problem. That's the difference of the zero shot, one shot, and few shot. But as I mentioned, this is probably very fake because they probably already learned the similar pattern in the training data set because the data set is too large. Probably in the training data set, they already learned some similar patterns. They just remember the pattern. It's probably not a zero shot, one shot, or few shot. We don't know. Okay. That's the GPT-3. Now, let me introduce two new terms. First is prompt learning, and the second is instruct learning. So, what's prompt learning? The idea here is, firstly, we have pre-trained a model, and we want to know which language can be understood by the model. So how can we make the model understand human beings? And after some studies, we find that the model can understand a template. We build a template. We assume the model can understand this template. And then we just convert our data to this template and make it easy for the model to understand us. That's prompt learning, right? You see here, we didn't change the model, right? We didn't change the parameters. We just convert the data or convert the way we communicate with the model. For example, you give the model instruction, I convert your instruction to the template. The model probably doesn't understand your natural language instruction, but now I convert your instruction to the template. The model can understand the template. So here we don't change the model; we just convert input data. That's a prompt learning. Okay. Yeah. So here, right? So you have a big data set. The data set has many different samples. You just pick one sample. That's one data point. You see, have you just input this to the model? The model can understand. How about you just use this format? Firstly is premise, and then is the true the hypothesis. Now I convert this one to this one. The model can understand. So like Allen Taylor characteristic finds. Is it true? Allen supports Taylor suite. So that's a natural language inference task. Now, if you just input this to the model doesn't know what to do. But if you input this format to the model can output a yes, no, or maybe. Basically, the idea is just converting the data format. It's a sort of data pre-processing. That's prompt learning. Actually, now we have a new job, prompt engineers. Prompt engineer, basically, they just convert a different format, convert data to different formats. They don't train the model. The model is the same. Now, the second technical term is instruct learning. So what's the idea of instruct learning? We want the model to solve some problem, right? To help us to finish some tasks. However, we don't know what's the task in the future. We don't know, right? There's too many different situations. How can I do that? We just train the model with some common tasks. Like maybe in the future, we have 100 different tasks. But we don't know we have new tasks or not. How about we just pick maybe the most important 20 tasks. We use these 20 tasks to train the model. By training from these 20 tasks, the model knows human language. The model knows human language. And the model has a sense of how they can communicate with human beings. And then they can just to finish unseen task in the future. So by these, maybe we have 20 training tasks. By these 20 training tasks, they want to have a better understanding of human language. And after this training is finished, we assume they already have a good understanding of human language, and then they can just to solve the unknown task. And that's the idea. There are different tasks. For example, the training may be common sense reasoning, maybe translation, maybe sentiment analysis. So the new task is natural language inference. So now let me give you a comparison between the prompt learning and instructor learning. Firstly, prompt learning, no training process. Because we don't change the model, we don't update the parameters. We just hire some people in Skill AI and they say they convert the data to different format, convert the data to some prompt format. So they are confident that they format the AI model can understand the format. And for instructor learning, we needed to update the model. We train the model with some important tasks, probably the most popular tasks. And later, we just give them the new task. For prompt learning, I believe we still need to give the model the format they want. Okay. So you see here, I believe instructor learning is better than prompt learning. Instructor learning help model to become smart. But the prompt learning make human more like a machine, to make a human more stupid. That's the difference. Yeah. So that's a key difference. So prompt learning forcing human beings to feed the machines. Instructor learning forcing machines to feed human beings. That's a key difference. Okay. Any questions so far? Good. So today we focus on instructor learning or InstructGPT or ChatGPT. So I just introduced instructor learning and also prompt learning. We know we also learned something before. It's pre-trained fine-tuning, right? Let me introduce their difference. So for pre-trained fine-tuning, it's the approach used in BERT or ImageNet. We just use a large data set to pre-train the model. Now we have a new task. We just build a new data set by a specific task. You give me a new task, I need to fine-tune the model again. Right? One task, one data set. So this is probably not efficient, right? Because in the future, you may have 100 different tasks. You have to build 100 different data sets or to tune the model 100 times. That's not efficient. And then then the prompt learning, you have to force human being to feed the machines. That's probably also not good. And in instructor learning, we pick some important tasks to train or to fine-tune the model. Later for new tasks, hopefully they already have a good understanding of human language and then can communicate with human beings. That's their difference. Now, so for InstructGPT, they have we have a new idea, new term, RLHF. RLHF means reinforcement learning with human feedback. So what's the idea here? The idea here is just to label the data. Just label the data. Actually, it's very easy. So That's why I believe most of work actually was finished by skill AI. If you like, you can check the paper InstructGPT. They mentioned the skill AI. So because of ChatGPT, skill AI is also a unicorn. Okay. Yeah. So now let me introduce RLHF, InstructGPT. Firstly, we still have a frequent model, and then we use some instruct tuning. But here the difference is we want to build a reward model. Then we use this model to give the GPT feedback. The GPT learn from feedback to generate the answer human-like, more like human being. That's the idea here. So let me also briefly talk about this chain of thought here. This is probably a trade-off, right? Because eventually we want to make the model very smart. We just use normal human language, just the way you talk to your fellow student, talk to your parents, talk to your friends. However, today the model maybe still not good enough. So we have to guide the model to solve the problem step by step. That's why we need a chain of thoughts today, chain of thought. So here, let me give you an example of chain of thought. So first thing, so here is a question. The writer has 5 rows. Divided 2 more kinds of rows. Each kind has 3 rows. So how many rows does he have now? So if you ask the model this question, the model give you an answer. Now, how about you give the model a new question, a little different, maybe more challenging. But sometimes the answer is wrong. So why the answer is wrong? Because the model has all the information from the internet. Probably the model memorizes some patterns. So here the model maybe just get something from his memory. That's why sometimes it can be wrong. So now we want the model to solve this problem, not to find something from his memory. So we get the model to solve this problem step by step. Firstly, Roger has 5 rows, right? 2 kinds of 3 rows. Each kind is 6 rows. So each is 6 rows, right? So 5 plus 6, 11, right? Step by step. So by this way, the same question is the model also solve step by step to get the good answer. So probably this is maybe finding something from the model memory. This one is solving the problem step by step. So this is intelligence. This is memory. It's a difference. Probably that because today the model is not good enough. We have to guide the model. Okay, yeah. More example of chain of thoughts. If you like, sorry, it's too small. Right? If you like, you can check after class. Okay, now before I introduce the technical parts of InstructGPT, now let me briefly give you a summary about the contribution of InstructGPT, because the key part of ChatGPT is InstructGPT. Firstly, firstly, we can see improvement in following human instruction, because we want an answer we really want, right? Not something nonsense. And also, InstructGPT is better than GPT for giving correct answers. And that's important, right? In the future, we want to ChatGPT in our life or in office. We need to make sure answer is correct. That's also very important. And also, they did a better job for controlling the output, make the output aligned with our society. We cannot generate something bad. And also, they have a better generalization performance. They just need to learn some important tasks. For example, they can just to solve maybe 100 different or 1,000 different new tasks. Generalization and performance is also better. Now, let me give you an overview of the process for InstructGPT, RLHF. Before I introduce RLHF, let me briefly introduce the strategy of reinforcement learning. So this figure just show you how can we do reinforcement learning. So normally we have an algorithm. So we have an observation from the environment. So by this observation, we make an action. So action now affect the environment. We get feedback or reward. Now by this reward, we use this reward to update our algorithm to make a better decision for next step. That's just a rough idea of reinforcement learning. Now the difference is, for this reward, we want to give the reward only human feedback. We give the reward human feedback. So that's the process for RLHF. So how can we use RLHF for training AI model like GPT? We have 3 steps. Firstly, we collect the human feedback. So how can we collect the human feedback? Now, for example, we get a blog post from internet. Now we can ask the model to write a summary, different summaries. We can also hire some people to write a summary for this blog post. And then we just hire some people to score these summaries. Right? For example, J is better. This one is J. This one is K. J is better than K. So now we can by this way we can build a data set with labels, because that's the data. That's the label. We have a data set with labels. Now the second part is we need to train a reward model. So how can we train the reward model? Still, we know we have one blog post with different summary, right? As we already know, J is better than K. We want the reward model to learn by this information. Then it's just a normally supervised learning. You have a data set also with labels, just use supervised learning. to train this reward model. Now, after we have this reward model, we have a new blog post. We ask the model to write a summary. And now we use this reward model to give a score of this summary. It's good or bad. So in number 3 step, the reward model already trained. So we use this reward model for training our product model to train this model. That's the process for using RLHF in training GPT. By the way, this work was also published in 2020. This work was also published in 2020. But why not why cannot we publish ChatGPT in 2020? Because we already have GPT-3 and RLHF. It's a little different. But the key idea is here. You see, that's why the engineering part is so hard, right? Even they already have all the techniques in 2020, they still need 2.5 years to put everything together. Right? So implementation engineering is very hard, very challenging. So now, let me show you the process for InstructGPT. So how can we use RLHF to train GPT-3 or to build the ChatGPT? By the way, later you find this process is a little different from this process, but both work were published by OpenAI, but they are a little different. So for ChatGPT, firstly, we have we got a prompt from the dataset. It's a question. We sample a question from dataset. We ask the employees from Skill AI to write an answer for this question. Now we have a question, we have an answer. That's a data point with a label. It's just a training data point. So in this way, we can build maybe 20,000 or 500,000 samples. Now we have a good training data set, for example, with 500,000 data points. Then we use the data set to fine-tune to train GPT-3. Right? That's just supervised learning. Right? The name is supervised fine-tuning, but that's just the most widely used supervised learning. Very common, very easy. Okay, that's the first part. Actually, if you have enough budget, also if you have enough human labors, you can deploy this model. You can deploy this model to ChatGPT. Assume you have enough training data set. You have enough well-labeled training data set that you can deploy this model. This model should be good enough. But in US, the human labor is very expensive. So we cannot scale this strategy too large. Now that's why we need a second step and the number 3 step. So the second step is we want to build a reward model. So what's a reward model? Because now we already have a good model. How about we just refer to this model as SFT, we already have SFT. So we just use SFT to generate different answers for a question. For example, for each question, we generate 4 answers. Now we hire the employee from Skill AI to rank these answers. For example, D is better than C, C is better than A is roughly the same as B. We use this to train a new model. Now, for here, we also we have another data set. The label here is this ranking from human. The data generated by our SFT model. The ranking is from human. So here it also sort of supervised learning. We use this to train a reward model. Here we have a difference here. This part is much more expensive than this part. Because for the first part, you need to write an answer. It's more challenging. So here I just do the ranking. So the step 1 is much more expensive than step 2. That's the second part. Now we already have 2 models. First, SFT model, and secondly, RM, the reward model. We already have 2 models. Now we go to the number 3 stage. Still, we have a question. Now we just use this model. PPO is ChatGPT. Is our product model. We just use this model to generate an answer, and then we use the reward model to judge, to verify the answer. We use the reward model here. If the answer is good according to RM, we give them a high score. If the answer is bad according to RM, we give the model a low score. And then we just use this train. Eventually, we get a product named ChatGPT. You see? So here, step 1, we need a GPT-3 and the employees from Skill AI. Step 2, we need a SFT model. SFT model is output of step 1. And the output for the step 2 is RM model. Step 3, PPU, maybe we can just use SFT here. Just use that SFT or use GPT-3. And we use RM to fine-tune this model. That's just the whole process of training ChatGPT. The TA has something to say? Okay. Okay, any questions so far? I think this figure actually is the most important part for this lecture. That's the whole process of training ChatGPT. Okay, good. Now, yeah. So you see, for here, actually, we have the prompt data set. That's just the many questions. That's just the answers. So for this part, it's much more expensive than this. So this part, we need to write answer by human. This part is just the ranking. So let me go to step 1, step 2, step 3 to explain them, give you more details. For step 1, we wanted to collect demonstration data and train a supervised policy. I think these terms are not easy to understand. Demonstration data just the answer, right? The answer to the patient or the label of the data. A supervised policy here just a model, something like GPT-3 or better GPT-3. Now here, let me show you some examples. For example, here is the patient. So we want to create a shopping list for this recipe, right? But we want to cook something, that's the recipe. Then that's the patient. Now we ask the employee from Skill AI to write the shopping list for this recipe. So here is the answer from human being. You see, that's training data point. Yeah, we just use many examples to fine tune GPT-3. So I think the process is very easy. We just build some questions and hire people to write answer to these questions. So now, actually for here, I also want to briefly talk about that. So for the employees from Skill AI, they can contribute different data points, right? So firstly, we just ask these people to solve any task they want. We just need to make sure the answer is correct. And the second, we ask these people to build actually multiple query response for the same question. To build a different correct answers. And the number 3 part is user based. So here, let me explain. Because OpenAI has a very large user space, so they already have some important questions from the users. The user maybe want to ask ChatGPT to make a PowerPoint for me, or to make a recommendation. How can I win the World Cup, or make different questions, right? So maybe some random questions. So how about we ask these employees from Skill AI to answer these questions, to write an answer for these questions. Okay, that's just a different way how they contribute. Yeah. So here is a table from OpenAI. You see, for different stage, how many samples do they use? SFT, RM, PPO. Yeah. If you like, you can check this after the lecture. Just implementing details. Yeah. So also, it's very interesting if you like. So what kind of questions the user need the most? Right? You see, number 1 is generation. you want to write a summary for a specific report. An open QA brainstorming chat rewrite. So here is some example, like you can just check the lecture. What's brainstorming here? And let me list 5 ideas about how to regain energy for my career. And generation, write a short story where a bear goes to the beach, makes friends with a seal, and then return home. That's just some examples. Okay. Yeah. So yeah, there are many examples. I encourage you to check them after the lecture. So for this SFT model, we know we just do a supervised learning. So for supervised learning, we know it's a model, right? We need a loss function. So what's the loss function here? We just predict the logics, and also we have a labels. That just use a normal cross entropy to build a loss function. Because this data set is so tiny. Do you know why the data set is so tiny? Yeah. Very good answer. Yeah, because it's too expensive. That's why. That's why it's so tiny. So they train them 16 epochs. I hope you remember for pre-training model like GPT. Usually you just train 1 epoch. So here they train 16 epochs because the data set is too tiny. And they use something like code and learning rate, like you can check out the class. Just indicate the learning rate. And that's just some hyperparameters. So here is their observation. Actually, for SFT model, they observe the model overfit on validation after 1 epoch. But the model actually can get a better performance compared to human being. That's interesting. That means there is misalignment between machine and human being. Even it's overfitting on some accuracy on matrices, metric. But for human being, the answer is still better. Okay. Probably we need to redesign this matrix. And question from TA? Yeah. If you have any comment, let me know. No? Okay. Yeah. So as we mentioned, because it's so expensive, that's why we need a new strategy to build a larger, even larger data set. That's the second part, the reward model. So now, let me also briefly explain the reward model. How can we train this reward model? So that's step 1. That's step 2. So the people are the same, employees from Skill AI. But this one may be $20 per hour. This one may be $5 per hour. This one is much more expensive than this one. It's just ranking the answer. So because in step 1 is too expensive, we want to build a new model, the reward model. So how can I build a reward model? As I mentioned now, we just use the SFT model to generate different answers. I hope you remember why can we generate a different answer to the same question? Because it's a symbolic, right? ChatGPT based on symbolic. Now we ask a human being to rank these answers. A good answer should, a better answer should have a higher reward. For example, here J and K, there are two different answers. For human being, we believe J is better, and then the reward Rj should be larger than Rk. We should build a loss function to encourage Rj larger than Rk, right? Or to encourage Rj minus Rk larger, the difference Rj minus Rk, the difference larger. So that's how we build our loss function. So here is the loss function. So here, W here means winning response, or the winner. The judge is a human being. Right? For human being, YW is a winner, YL is a loser. So that's the reward of YW. That's the reward for YL. So that's the sigmoid function. I hope you still remember the logistic regression sigmoid function, right? It's just something like that, right? So it doesn't affect the trend of this function. Now we want the difference between them as large as possible. That means we want to maximize it. We want to maximize it. However, that's loss function, right? Because we want to minimize the loss, so we add a minus here to minimize the loss, because we want to maximize this part. So here the K2 means because you have K different response, which means you have CK2 pairs. And that just hides through mass. You have CK2 different pairs. That's just a loss function. Okay, by this way we can train our model, the reward model. That's the reward model. Now we go to the number 3 part. For the number 3 part is training ChatGPT. We want to, how can we train ChatGPT? We use the feedback from the reward model. For this part, no human being, no human being number in step 3, just a GPU. The GPU, we just need a GPU here. By the way, here PPU actually is a model. If you like, you can check these papers for the PPU algorithm. Yeah. So we don't have enough time because PPU is also another lecture. I encourage you to check PPU after class. Here, you just remember the key idea here is to use the feedback from this reward model to train this model. Let me also briefly introduce the implementation details of this step 3. Firstly, for reinforcement learning setup, it's a banded environment. So what's banded? Banded means the model only consider one more step, only one step, only short-term decision, no long-term decision here. Because ChatGPT only is predicting the next word, right? Not the next 100 word, but next one word to align with GPT-3. And what's the state here? It's just a distribution of all the possible questions from the question or instruction. What's the action space? It's just all the tokens in GPT-3, 50,000 tokens. And what's the reward? It's based on the reward model we trained in CF2. So here it is a policy. We want to maximize the likelihood for next word. For PPO setup, we have two models. So the actual model is SFT. We trained in step 1. So actually, I believe so here we can also use GPT-3. I want to ask the TA. I think we can train over a long time. Yeah. So yeah, I believe we can also use GPT-3 here. Assume we can train a long time. But here I believe why they want to use SFT here, because they want to make the training more efficient or training shorter. Because SFT already trained. Like SFT is already a high school student or college student. We use GPT-3 here, just a child. The feedback is from the second model. Is the feedback is from his reward model. Yeah, that's the whole process. Yeah. So let me also introduce the loss function in step 3. Loss function, we have 3 parts. Firstly, we want to maximize the reward. And then the second part is we want RL model or this ChatGPT model or PPO model. Sorry, so many different terms here, but they are the same thing. We want the output model similar to the SFT model. Because the SFT model is very expensive, right? Very valuable. As SFT model is built on top of human beings. And also we want to make sure that the output model, the PPO model or the ChatGPT has the same power of GPT-3 to avoid the decline in the model capability on future public data sets. That's the 3 parts of the loss function. Okay. Now you can see the real performance of ChatGPT. You see, so here PPO is the ChatGPT. So you see better than SFT, better than GPT prompt, better than GPT. So here, Flynn T0, they are fine-tuned. They are actually to data sets. People use data set to fine-tune GPT-3. You see, the PPO is still better. And so here is the winning rate. You see, PPO has the best chance. PPO is the best for winning. Also, we want to make sure the answer from ChatGPT is correct. So correctness is also very important. You see on this benchmark. So the instructor can help us too. improves performance. So here is an example of generalization. So you see, I think so here the author want to share even you use different language, GPT can follow instruction in other languages. And also here the difference between GPT-3 and the InstructGPT. InstructGPT can give us better answer for summary. But sometimes we know ChatGPT can still make some very simple mistakes, maybe confused by instruction, or sometimes it's too cautious. We want them to answer the question directly, but they are too cautious. That's the bad thing today for ChatGPT. So more limitations of InstructGPT or ChatGPT. Still, it's very expensive. So even for this tiny model, roughly 7 billion parameters, we need 300 GPU days. That's a lot. And this part of the alignment process is not transparent to the public. We don't know how to explain. Still can generate some bad answers, like biased answers. The model still make mistakes. And for some domain-specific knowledge, like chemistry or physics, they cannot give us a good answer. That's the limitation for ChatGPT today. So here is a summary for InstructGPT. So actually, InstructGPT maybe just a small version of ChatGPT. They are very similar to each other. So we use the RLHF to train a policy based on the feedback from the reward model. Policy is just policy here means a model. So InstructGPT can give us the answer human-like, following the human instruction. And they can get a better generalization performance. Even for some unknown task, they can give us good answers. That's the paper for InstructGPT. I'd like you can check after that. Now, let me use a few minutes to briefly introduce GPT-4. Again, so we don't know the details of GPT-4 because they don't publish. They didn't publish too many details, but we are confident that the techniques here are correct. So let me briefly introduce GPT-4. So you see, that's the author of the team for finishing GPT-4, right? So many people. So I think the key difference between GPT-4 and GPT-3 is the ability of multi-model. They can take an image or take a language or even take a video as an input in the future, I believe. They can do a lot of different applications and also get a better performance. But again, we don't know the technical details. They didn't publish. They didn't open source. If you like, you can check on the internet. There are some guessings. So here is an interview with OpenAI. So ChatGPT is an MOE model with 8 experts. Each expert has roughly 200 billion parameters. Yeah. So what MOE we start in next lecture. So people claim the ChatGPT or GPT-4 version of ChatGPT use MOE. We start the MOE next lecture. Yeah. So a highlight of ChatGPT is you can input image, video, or voice, different formats to ChatGPT. And ChatGPT now, GPT-4 is very powerful. So here are the benchmark results. You see they can even achieve sometimes better results than human than in the exam. So here it just shows you the results. They actually rank the top 10 of the test takers. Right? It's pretty amazing. They are better than 90% of the human beings for this exam. Yeah. So also now people started the loss prediction by GPT-4. So here the idea is you build a few small models, right? So that's the loss score, right? That's the first model, second model, number three model, number four model. Now you have 4 points. You want to predict with larger model. Can you predict the points? Which means we want to predict with more computation, larger model. Can we get a better performance? Right? Here it's a low score, lower is better. So people now use ChatGPT to do this kind of prediction. Yeah. So you see now they can build a very good curve. Also, they want to not just predict the loss score. They also want to predict some meaningful accuracy. Like here is human evaluation. It's a sort of also a metric. They want to predict this kind of accuracy. But the idea is similar for predicting a loss. So before GPT-4, you see on some application, people believe so larger model worse performance. But when GPT-4 was proposed, you see GPT-4 can still get better performance, can help us to have a better understanding on the application and also the power of the AI model. So still today, for GPT-4, we also have some concerns, particularly hallucination. They just build something not existing. That's a concern for today's GPT-4. Yeah. Also, have you tried the ChatGPT last year? You found that they only have the knowledge before September of 2021, but they are updating the model frequently. But that means they still do not have the latest information. We just use a model. So we need a combination between a search engine and the AI model to build a perfect product. Yeah, and also GPT-4 still can give us wrong answers. Okay. Yeah. So how about I use a few more minutes to briefly go over OpenAI's slides. That should be give you a summary for the GPT and the ChatGPT. Maybe just 5 minutes, then let me briefly go over the key part of OpenAI's slide. Okay. Yeah. So you see, so from the OpenAI slides, you can see they have a different stage. Right? Firstly, pre-training. We learned in GPU3, right? You have a data set algorithm, just predict the next token. That's a base model, like a GPT Llama. After this part of the training, after this training finish, you get a GPT Llama form, right? As I mentioned, you can deploy this model. You can deploy this model, but this model may generate some bias content, right? It's just the June of 2020 GPT-3. And then supervised fine tuning is today we learned step 1. You hire some people from Step Skill AI. They generate some like 100,000 data points for us. Right? We train the SFT model. Right? So we can deploy this model like BQ 13B. By the way, if we have enough people, enough budget, I believe this one model is probably the best. Because all the model of all the training data sets, all the training samples of this model is made by human being, right? If we have enough people, enough budget. And then that's step 2. Step 2, we want to train the reward model. That's the reward model, which means that's not a product. We use the reward model to help us to train number 3 step. You reinforce learning to train the real product. That's ChatGPT. You see, that's OpenAI's slides. It just give you the summary of the whole process. How can you build your ChatGPT from scratch? Have any question for this page? Yeah, so today lecture 8, we learned this part in lecture 6. Yeah, so for the pre-training part, you see, they use a lot of data, right? Like a Common Core, C4, GitHub, Wiki, books. So the number of epochs, the highest is Wiki. Do you know why Wiki is the highest? Yeah, good, yeah. Because I think that the quality of Wiki is highest, right? The quality of the data is the best for Wiki. So maybe internet has too many random information, right? So GitHub only 0.6. I believe it's too technical GitHub. Yeah. So yeah. So how can we do tokenization? You see here an example. Here is data from internet, and then we just token, and then we just convert them to integers. As I mentioned, the size is 50,000 different integers. Yeah. So here are 2 examples. for GPT-3. Yeah. Firstly, in the real GPT-3, here Llama consider another GPT-3 by Facebook. You see, that's different kinds of GPT-3, the number of parameters, number of layers, the dimension, number of heads. You should know how can we compute the number of parameters by just these type of parameters. So training GPT-3 is very challenging. You need at least 1,000 GPUs to train several months. You need a budget of maybe $5 million US to just train GPT-3. For training Llama, need 2,800 GPUs, 21-day training, budget about $5 million US. By the way, I believe the real cost is probably at least 30 million or 20 million, because you cannot just train it once. You make lots of mistakes. The hyperparameters, you kill the hyperparameters. The real cost should be much higher. Yeah, that's the pre-training. Right. Yeah. So okay. Very good. So we don't have enough time. Yeah. I feel like you can check this slide after the lecture. They also have a video on YouTube. Please. Okay. Thank you so much. That's it. Do we have a tutorial? How about after 3 minutes? 3 minutes. We have a tutorial.